Do the big players, whether it's Google that you mentioned, of the Apples or Amazons or Meta, Microsoft of the world, do they have advantage in the deep learning models? How do small companies can focus? What is that they can do with the deep learning? Is it just that they continue to use the models that are developed by the big companies, or is there something that small companies can do as well? What is happening now? What's going to happen in the future with respect to deep learning? Hello, everyone. Welcome to one more episode of Unlocking the AI Advantage podcast. This is your host, Ramesh Danta. Today is an interesting topic that we're going to go deep into. We'll be focusing on deep learning. And typically, as you know, if you've been attending this series, that we try to balance between technology and business. And today, even though the topic is kind of technical, deep learning, so the tendency is to go deep into the technology, we will try to still balance out the applications of deep learning to the business and the outcomes on the business, right? So, but still, given the topic itself, we may be, at least initially, going little deep into the technology itself. The discussion gets started. I would like to bring two panelists. So Tooraj Helmi, who is the CEO and founder of APSY, and Jeremie Farret, who is the CEO and CTO of Mind in a Box. With that, Tooraj, please introduce yourself.
Thank you, Ramesh. Hello, everybody. My name is Tooraj Helmi. As Ramesh said, I'm the CEO of APSY. I have a long academic track in engineering, MBA, and so on. I do have a PhD in econ as well. Since 3 years ago, I've been acting as the CEO and founder of APSY. At APSY, we use AI to generate software. Before APSY, I was head of product and engineering at Builder.ai. And I'm also, since 4 or 5 years ago, I've been actively researching on using AI in generating software. I do have about 20 years of experience in technology, and I would probably the last 5 years have been highly focused on using AI in solving one complex problem at least.
Thank you, Tooraj. Jeremie, please.
Yes, so I've had contacts with application domain of AI starting in the 90s, and as well advanced analytics. The way I've touched into the subject was computer vision, as well as something that wasn't called AI at the time, which was a lambda calculus. Right now it's called symbolic AI, as opposed to connectionist AI. We've been creating a department of advanced analytics and AI within a Microsoft Gold partner company, which has been operating since the 90s. And that department started in late 2016. It doubled in size every year. And today, that's what created the Mind in a Box, which is now its own company, a subsidiary. What we do is equipment as a service. We started in advanced analytics, but very quickly we developed equipment for AI support, as well as services and consulting services in various application domain of AI. The main domain in which we are acting today are domains which are regulation heavy. Telecommunication, smart supply chain, emergency services, our domain, and government agencies are customers of ours on 4 continents today. Thank you.
Excellent. Thank you both to the audience. As you can see, so we have panelists with deep expertise in AI and the knowledge, of course. So let me get started, Tooraj, with you. First, I would like to get an overview of deep learning for the uninitiated. So when I do a research on deep learning anywhere, so suddenly you see these 3 circles that show up. Deep learning is the smallest circle, and the machine learning and AI is the largest circle. Anyway, so in that context, so what is deep learning and why should we be caring about it?
Sure. So yeah, I've seen those circles as well. So maybe the easiest way is to go from the other circle, which is AI, which you mentioned. So AI has been, that term has been there since maybe the 70s, but overall, when we say AI, probably we are referring to simulating what humans can do in terms of their intelligence. And these are around like the way that humans can learn, their reason, and so on. So in general, when we think about intelligence, we think that there are specific things that we call something intelligent, being sensing, recognizing things, interacting with the world, deciding, and so on. But I've been thinking about that subject. What really intelligence mean? And for myself, I categorize that into 4 different categories, which are the first one is perception. Something has to be able to perceive the world and make sense of it. The existing large language models, for example, on top of sensors, is a good example. They understand language. On top of that, intelligence systems normally have some expertise, so they understand something beyond the general sense. And again, for people who have some background, they know that, for example, large language models can be fine-tuned to a specific task. For example, they can understand medical terms better than regular generic LLMs. I think there are 2 other aspects. One of them, which is important, to skills. Like just understanding something is not important, is not enough. We should be able to act upon that. For example, we see robots or autonomous driving systems that utilize that data and then do something. And so when we see these type of things, we see, oh, there is more intelligent. And I think the last piece, which should be there for any intelligent system, is evolvability. So something which we consider intelligent has to evolve over time. If it is static, it might be doing something. We might consider automation. Again, we might not consider intelligent. Now, going back to your question, deep learning, there are different ways that AI is implemented in technology, and one of them is deep learning. Deep learning is basically can be applied to, I would say, the first 2 levels of intelligence: perception and expertise. And deep learning is comprised of these small units called neural cells, and once they are connected together are called neural networks. And these are nothing but, if people have done regression statistics in the past, these are just simple equations that A equals bx plus c. And then when you provide data to the input and output, we can interpolate these kind of coefficients. Once you have billions and trillions of these neurons connected to each other, then you can train them with massive amounts of data. For example, that's what's happening with LLMs, that they train them with all of the data in the internet, and now kind of it understands all of the probabilities that exist in the language, for example.
Great. Thanks, Tooraj, for getting us started. With the deep introduction of the deep learning. So, Jeremie, I know. So you play a lot with this various aspects of intelligence. So can you talk about the different links, and also you expand your domain to AIoT, the IoT field as well. So if you could connect the intelligence here as well as to other domains.
Well, I think that yes, the general perspective and how people present, intelligence, and maybe we'll come back to this in the second section. There's this temptation of presenting it, and it's a good way to explain it to a general audience is to explain them through human characteristics. And sometimes it works. Like, for instance, I will bounce back on what Tooraj has said, and the terminology varies, but the inputs, the way we encode knowledge, the way we act with the surroundings, and the way to actually learn from the general processing in order to progress and to increase performance, are good characteristics with respect to the functional, the functional analysis of this intelligence. And so when we're talking about common classifications of AI, AI is looked at in very various ways, because some people will use it by analogy with organisms, right? So they will use the networks of neurons. And we know that the network of neurons that has been used for decades, and there has been development about neural networks for decades, way before we were talking about deep learning. people will describe them as systems. And there, we also have decades of experience talking about expert system, talking about functional programming, and sometimes even going to the 19th century with looms and things like that. So there's a continuity, with respect to those descriptions, which are more system-oriented. I would say that with respect to AI, because the capability is extending so much, all those descriptions apply, but the capacity that we're putting into those different categories is becoming wildly different, and approaches the capacity of operators, approaches the capacity, and sometimes overcomes the capacity of a human actor. So you talked to me about AIoT because I think we discussed it before. When you apply AI into emerging domains such as edge computing, such as IoT, suddenly you make the AI and approaches such as deep learning even more powerful. So I will just use two illustrations, and I think we'll go into domain later. But when you want to look at this capacity of AI describing all the AI function, right? You can take the image of an autonomous vehicle, right? The autonomous vehicle has a variety of senses. Tooraj was talking about perception, and it perceives the world in ways that we cannot as humans, right? It has telemetry, it has a lot of sensors that we humans don't have. Then it has an expertise, which is encoded. It has the skills to conduct the vehicle, and then it evolves. And this is AIoT, AIoT at a certain point is becoming ubiquitous because it comes out of the laboratory, it comes out of your professional environment, and it goes into the city, it goes everywhere where you are. It is into a smart object of various sorts. And because it applies to a sensing that becomes more and more standardized, such as video feeds and a number of sensors, then we can have a mass of data that becomes more and more powerful, and their deep learning becomes very, very efficient at classifying and absorbing this very large amount of data in various points of computation. So it can be directly in the vehicle or centralized when you really need the power to crunch the data and to have complex inferences, complex thought, complex calculation.
Jeremie, that's a great example of the how you start with autonomous vehicles, where the the aspects of deep learning can be used. It's a perfect example. So Tooraj, like that. So what are the examples where I know you're doing research as well, but whether it's an APSY or where you have seen a good example of a deep learning where it's applied?
Sure. So these days it's almost they are everywhere, deep learning and AI. So I mean, the easiest, the closest one to all of the people is when you go these days to any office system you use Microsoft systems or use Google Workplaces. You see that all of them are kind of integrated with AI. And by the way, when I say AI here, its implementation is these days is mostly on top of some kind of deep learning, being LLMs is one of those examples, large language models. So Gemini from Google is one example that is a large language model by Google. Now, if you go to your Google Docs and you see there's an icon there that allows you to just type part of what you want to type, everything else comes after. Same goes with Microsoft Word. But other than those, there are systems, like more complex systems that are trying to use AI and deep learning to mimic what humans can do and surpass human capability, like Jeremie said. APSY is one example. What we are trying to do is to make app development, software development be autonomous by AI. So you can imagine that you go and talk with AI, talk about your ideas. It understands what you are saying, and then it interacts with you. It asks questions to understand what you want to build. Also, it helps you figure out what you want to do, because for people who have tried to build an application, they know it's not that they have everything hashed out in their mind. So it's a kind of interactive session. So it starts from there to observe, to get the information from the person or system that is going to use the AI. Once the information is used, then the next step, which is what I call skills at the beginning, starts. Now you have the knowledge. Now you are going to be applying back into the system. So in our case, that would be generating software, for example. And this process is interactive. Normally, you have to build something. You go back to the user, get more information, and so on, which is kind of the way that humans normally work. We are seeing using of AI in medicine a lot these days. Like dentists are using AI to detect cavities. Doctors are using it for image processing images and so on. So these days, it's very hard to not seeing deep learning and AI not being used in our day-to-day matters, basically.
Great. So, Jeremie, you got started with autonomous vehicles as it related to AIoT, but what are the other examples you're seeing in telecommunications or other regulatory areas that you're operating in?
Well, yes, and as I said, in emergency services as well, we touch with medical application. It's fascinating how deep learning can be applied in examples that blow the mind, right? At a certain point, there was an application for phones that was listening to people coughing, and that was able to predict with a very high performance whether people had COVID or not, right? And so here, that's a very good illustration of where deep learning shines, because where deep learning shines is where you don't necessarily have a very good understanding of how you're going to get a chaotic or complex manifestation and bring it to actionable intelligence. And here there's when you present it to even a developer, there's a kind of a magical aspect to it, because it's very much a black box process at a certain point, as opposed to symbolic AI, where you have to write explicitly every rule or an expert system. Here in deep learning, you have an autonomous process, and I believe Tooraj used that term, and I think it's a very important term to coin deep learning, that actually takes all your data and will learn from your data in ways that you cannot even describe as a human engineer or as a specialist. And so here, some examples, I talked about medical. There's a lot of medical application. Of course, in medical, as in transportation, every time that there's a life on the line, and because what we described is essentially a black box process, so it can be explained, but it can never be completely demonstrated, as opposed to methods that are driving right now, subway system without pilots, etc., which are using formal methods, Alice, B method, etc. You cannot use that for deep learning. So you can statistically demonstrate that it's going to work in a large amount of the case, that it provides a good performance. But if you are in the medical, you're going to provide assistance to the diagnostics. If you are in emergency service, you're going to provide assistance to the human. The human is very much in the loop. Where you can have a fully automated process, for instance, are in supervision and planification of resources, for instance. You see, a method where you're managing inventories, a method where you are going to ordinate a production method for an entire day, or maybe adjust them. Smart supply is very good with respect to this, because at the end of the day, in the production system, you're going to have still some human in the process. So you can take a fully automated answer. You still have some safeguards in the process. The same will apply in services, such as in the telecommunication services, where you want to route extremely fast, services for humans. So receiving a large amount of emails, going through those emails, routing them very fast to the right technician so that the system is very efficient. That's something that we worked on for Bell Canada with very, very good results. You can win a lot of time, you can win a lot of money applying deep learning there. And so I hope that later on we'll be able to describe where deep learning can be very efficient, where deep learning is actually something to look very carefully. We keep, and I just want to bring the attention of the audience on this, we bring very often so far examples that are in computer vision and in natural language processing. And that's because, we've been working on that data for decades. So we know that data extremely well, right? We've been having automated call center for decades. We've been having a computer vision even for AI since the late 20th century through the NASA development. And so we know those environments very well. We can curate the data very well, and that's a part of the answer, because maybe we'll have the luck to get into that aspect. That you have to have very good data and a very good knowledge of your data for deep learning to be efficient, and for deep learning to be reliable.
Excellent. Which is, given the reliance on data, right, that it needs to be there, and then deep knowledge of the data. So Tooraj, let me get started with you. So the question is, do the big players, whether it's Google that you mentioned, the Apples or Amazons, or Meta, Microsoft of the world, do they have advantage in the deep learning models, right, given that they have access to vast amount of data? If so, or whatever that is, but how do small companies can focus? What is that they can do with the deep learning? Is it just that they continue to use the models that are developed by the big companies, or is there something that small companies can do as well?
Sure. So I think there are two ways that companies can be engaging in this with AI and deep learning. One is building the model itself, right? So building ChatGPT or Gemini, and those are massive tasks. They require billions of investment, and they requires a lot of engineering and data. All of those are there. So probably for a small company to start competing with these large companies, OpenAI, Microsoft, Google, and so on, it's doable, but it's going to be very difficult unless there is a way to really differentiate it from a core theoretic aspects of what they are doing. But
Yeah.
that's not the only way that small businesses or companies are engaged with AI. So I would say maybe 90% of companies are not building their LLM or models from scratch. They are using existing models, especially in language models. Now these days, uh, these existing language models such as OpenAI, GPT, or Gemini, and so on, they are available out there, and companies can even fine-tune them. So at the beginning, I talked about the expertise. So there are two ways you can use an LLM. You can just go there and say, put your prompt there and ask your questions, and it is going to provide useful data and can be used just like that. You can use it in many different applications. But if you want to go further and you have, as a small business, you have some data that you have collected over time as you interact with your users, and you want your models to consider that, then there are two ways that you can use that. One of them is fine tuning, and fine tuning is getting one of these existing models and train them again using your own data so that it understands how to analyze that. Another recent thing which is out there is called RAG, retrieval augmented technology on with LLMs, and that's being used for enterprises. So in enterprises, when you are using an LLM, for example, you want the responses to be tied to the data that an enterprise and organization has. So
Mm-hmm.
what RAG does allows LLM to have access to the data that your enterprise, your business has, and then uh, and adjust the responses based on that data. So that is also becomes very available. That doesn't require fine tuning. That's just utilizing the data you have using existing generic LLM. So I think using LLMs most of the time is a good start. You can use them, and most of the time it's going to solve majority of the problems. Now, as you go deeper and deeper, maybe you get to some cases that existing general purpose LLMs or other type of models do not solve your problem. That's when actually you are at a good point. If you are there and you think that you want to build your own model, then you have find something very niche, and probably at that point you would be able to compete with the bigger players.
Got it. So Jeremy, so you're a small company as well, small business, I should say. So how are you playing, or how are your customers that you deal with are working with the deep learning models that are developed by the large companies?
Well, it's a wonderful time, and it's a wonderful time. Why? Because project yourself 15 years ago, right? AI was there. There was wonderful AI products, and the small actors couldn't play with them, right? Who had the means to have the Watson license from IBM? Certainly not Tooraj or me. We didn't have the money, and even if we wanted to play with Watson, we didn't have the code of Watson. We would have had a black box called Watson, and there was many Watson systems for many purposes, and we would pay by the time that we use Watson, by the number of queries that we have Watson. So a completely proprietary model where everything is protected, nothing is seen, nothing is an open box, right? And everything is protected. Then came all the pushes, and here I have to tip my hat to Google, which was a powerful actor to make all those elements that I think are fundamental for progress for AI. And so we came up with a lot of open source components, etc. And so for generative AI, for a while it was touch and go, whether we would go to an IBM model or we would go to a Google kind of model, And so at first we ended up having OpenAI, we ended up having models that were not so open. And what happened is that the concurrence in the GAFA came up extremely quick with open source model, which I don't think was the plan for Microsoft and Google. I don't think that when they came up with those products, they were not as open, they were not as distributed as they are today. And I think they're challenged, by the multiplicity of actors that are providing those models, that are providing open source, that are providing the original model. But that addresses to people like me and like Tooraj as small business. And I think that not everybody is Tooraj or me, not everybody is Mind in a Box or APSY. So I will try to address that question for other small businesses, right? Small businesses that don't know what RAGS is, they don't know at all how to fine tune OpenAI. For them, we might as well be speaking Russian. They don't understand that, right? And so I think that here still there is a lot of hope because they can come to companies like us. They can even come to product, ready-made product. And Mind in a Box actually has tailor-made appliance to do RAGs automatically and to make it easy to use for the customer and to do enterprise search very easily. And what does that do? That organizes all your enterprise knowledge, right? That makes it accessible through vectorization and other angle to and I cannot go too much into depth there because there's some secret sauce, but makes it available to those online models, right? That are extremely cheap and that are unbeatable right now. To make a query to OpenAI, for instance, even when you use the professional API, it has become so competitive so quickly that a small company cannot do money, right? Proposing resources to do generative AI, to do deep learning that way. It's too small and it's too cheap of a query. But you have this space where small companies don't know how to fine tune, how to do RAG, like Tooraj said, and then they can be helped by our company, by Tooraj, to actually have ready-made components or very good software application that can make use of that power very quickly. And here, there's some low-hanging fruits to be had, right? If you want to search in your knowledge, you can do that in your enterprise knowledge very easily, complementing the GPT. And so small players can come and provide services and provide solution to those small businesses that are referenced in that question. So I think this is an even better age to be in than the wonderful age that we were 2 years ago, even.
Okay, so continuing on a similar path here, we talked earlier, there are various aspects of intelligence, and Tooraj, you got us started on various aspects of intelligence. So the question, Jeremie, to you is that no technology can help with everything, right? Even though we want to say that, oh my god, this is the next best thing, all that stuff, but there are various aspects of intelligence, whether it's a creative intelligence, whether it is a emotional intelligence, or aspects of intelligence. And we know LLMs have been successful in some parts, but not in every part. For example, creating a content, it's amazing. ChatGPT, so we use it a lot. So, Jeremie, if you could talk about deep learning and its limitations in terms of what aspects of intelligence it's most suited for, and where we still have much further to go.
Yeah, so I think there's a great trap there, right? And this great trap is anthropomorphism, right? Because people talk about neural networks, because we consider intelligence as a human element, very quickly we are tempted to explain AI in human terms, but also very often, and it's not a view of the mind. Huh? Every week I catch some of the experts around me, thinking automatically in some way or another in anthropomorphic term. Huh? It's really difficult to completely remove that type of thinking when you're interoperating with an algorithm that's essentially a black box, but it has capabilities and limitations that are very, very, very different from the human. And so when we're talking about, for instance, creative intelligence, tribunals are already ruled out, and they've ruled out against creative intelligence, even though we may have for now, we may have the impression that there's creative intelligence, and generative AI is today incredible and the closest thing that we have to a general AI. So an AI that would mimic, the capabilities of the human mind. There's a lot of area where it still cannot perform as the human mind. So I would say that from the ones that you've described, analytical intelligence and creative intelligence are very far from the functioning of a ChatGPT today, which is still using a lot of approaches that are close to statistical processes when it comes to selecting the right answer with respect to the quantity of text that you've produced. So when you and sometimes maybe the audience has played with some parameters. People let you play with the heat, for instance. And the heat is the way you work with the variance, statistically speaking, so that you're going to end up with something that looks creative, but it really parses a lot of possibilities that have been extracted from data that have already been learned. And here, the trick, the illusionism trick, is the sheer gigantism of the data that has been fed by the AI, which is enough to give this impression of creative intelligence. So here, I don't want to, and it's not the place to go into philosophical questions here, but I will refer the audience to ask those questions maybe to a search engine rather than an AI, or an AI will answer actually very honestly about that, GPT. But I would say that it's more in practical intelligence where you find ways that are extremely similar and very effective, going to search for the same theme, pulling out solution, bringing out elements that are very pragmatic and practical to a certain question or a certain thematic that it shines actually. And for emotional intelligence, I would maybe refer back to I don't know if you have, or if the audience have watched Young Sheldon. And in Young Sheldon, they show a very old computer, a computer from the beginning of the 80s, and there was a program called Elisa, right? Who was simulating a human operator. And there's been a lot of article written at the time, at the beginning of the 18 on Elisa. It's absolutely fascinating. And if you look, it's not necessarily emotional intelligence, but it's an object that brings emotional, or that was bringing emotional consideration. And I would say in an hospital, and with the aging of the population, there's a lot of initiative that tend to bring AI for emotional support instead of human personnel, that tries to bring robots instead of pets, etc. And I think that AI can provide emotional service, but that doesn't mean that we should think in terms of emotional intelligence for AI. I think it's anthropomorphism there, and we should be very careful.
Got it. So actually, Tooraj, I will ask this question a different way to you, because you mentioned RAG. I think so when you're talking about how small companies can use, or other enterprises can use, above and beyond what big companies have done, the deep learning with LLMs kind of thing. So the question is, with respect to limitations, you said, hey, RAG is the way that you could expand on it. So first, my question is, doesn't it give one of the concerns that companies have is when they expose their data, right, in combination with chat GPT, whatever, so their own domain knowledge, secret sauce would also be exposed to the large companies, and again they will also get more information about your company. So there are concerns about that one. Is that a limitation of the area that we're playing in? Are there ways to make sure that that does not happen?
Sure. So what you mentioned is like the data privacy is definitely one of the major issues and concerns. I wouldn't say issues, concerns that companies or individuals have when they are using, uh, I would say, large language models probably these days, and deep learning, which is underlying. One great thing, at least from the legal standpoint, is that when you go and try to use RAGs or LMs in the form of a API and you pay for it,
Mm-hmm.
these companies are pretty clear that your data is not going to be used to train their models or be
Okay.
provided to other companies. So your data is safe, and these companies are Microsoft and Google. So you can count on what they say from the legal standpoint. Um, that's one way. I mean, so just using the black box approach is fine. But also, if a company really they wanted to have their own way of making sure that their data is for sure not exposed, there are like other ways to do so. All of these models have either open source or even these companies provide a smaller version of their models that could be ran within a VM that these companies own. So in that sense, everything that they provide to these models are kept within their own premise. So it's not going to be shared with the rest of the world. So there are ways to definitely protect against the data loss and data privacy issues. Uh, I would say that that's one issue that I see that companies normally think about. There are other things as well. One of them is at this point still cost has, like Jeremy said, it has lowered a lot significantly, and like companies can play around and build technologies on top of those, but it still cost is not low. So if you start using LLMs, for example, in your products, pretty soon you are going to see your costs are going to go high. For those, again, the good news is that all of these companies, there's a lot of competition at this point, and they are trying to reduce the cost by introducing smaller models that still work, but at a lower cost. Again, the other option I mentioned, running on your own VM, is there. So the computation cost is another one. The other case, which is if you are doing something which is more involved, I think, is explainability of these models, deep learning
Mm-hmm.
models. And what explainability means, so no, most of the time people try to provide their data to train these deep learning models, and then deep learning model understands and then starts predicting or prescribing or any of these tasks that are expected. But nobody knows why deep learning is making the decisions that they are making, the decision it's making. So this becomes important when it goes to regulated industries, and you want to have a justification, and you want to make sure that the decision being made is based on some reason. And that's a new topic that researchers are working on to try to make sense out of the decisions that is coming from the deep learning systems, to make sure, number one, it can be regulated, number two, it can be justified. And I think this is also an important thing when we can see like deep learning being used in finance or medicine. I think this is something which is pretty important.
Actually, that's very important. So I know you bring up a really good topic of explainability. So if we have time, we'll get into that later. Jeremy, on this particular topic about
Yeah.
how to segment the data between what enterprises have with respect to what large companies have, and
Well,
some of the challenges in implementing. So can you share some thoughts, please?
yeah. So first, I'd like to bounce on what Tooraj said, because that's what Main in the Box does, actually. We have some machines, we do GPU as a service, as part of our equipment as a service. We
Hmm.
port the open models. So again, some companies are able to do that. Some companies do not want to do that. And there's an interest in keeping your data internally. right? As Tooraj said, he quoted the Microsoft OpenAI. When you go through the paying API, they tell you that they are not reusing your data. That's true. The same thing can be said about Google, but there's a wealth of a pre-trained model out there. We cannot only think in terms of Gemini and ChatGPT. There are more and more now specialized, refined GPT LLMs out there that are already specialized for specific services or specific answers. There are such sites, and if there's a question, I can provide the list offline. But for your taxes, to build to do buildings, to look at transportation planning, etc., etc., you wouldn't believe the LLM that have been specialized everywhere, and those LLM, they may not respect the same licensing. So that's the first thing that I want to say, is that this argument that Tooraj says to run the LLM locally, it applies to people like Tooraj or me who can operate a LLM locally or on our laptops and use the software that for an IT professional even can be possible to operate, but with a good knowledge of the models that you operate and the constraints, etc. But also, you can take a offers such as ours, equipment as a service, and there's others that actually package those open source and make them available to you locally on your network, so that you're sure that nothing comes out. So I think that's very important. Also, to make an echo to what Tooraj said, and he's absolutely right. Right now, there's a big push for regulation. I think it's a very good thing. And I think it shouldn't be only the domain of the research, and I don't think it is. There's governmental agencies and a lot of regulatory bodies like FDA, the equivalent in Europe, etc., that are thinking about those questions. UK came out with a document. The European Community came out with the document. Canada came out with a legislation in these matters, and we're seeing all those frameworks coming up. Now, those 2 points being placed aside with respect to the caveats, right? And so, yes, we've talked a little bit about that, but I maybe it's worth insisting. Where deep learning right now is shining is in areas where we have 30, 40 years of experience, right? And we can reuse that experience. So natural language. And sometimes, some cultures don't have the luck that we have, speaking the French language, speaking the English language, where we have those models that have been honed and tailored for 40 years, right? And so suddenly you have a problem, because there's an inequality in the world right now, and there's a course, because some language are absolutely not covered properly with natural language processing. And so those people get cut, right, from this formidable wealth that is generative AI. So that's a very big cultural and societal question, right? That we have this cutting edge advantage for German, for French, for English, for those main language that have been, accumulating this experience of analysis of the language, and it's not the case for every language upon the world. So that's going to participate, in a concentration of application around those disciplines. So that's one of the example, natural language, where we have wonderful example. And in another example is, of course, computer vision, but I would argue that it's historically the first domain where we've applied AI. And NASA very early on for space exploration was doing object recognition using AI similar techniques. So those 2 domains, we know them very well. So what does it tell us? It tells us that, yes, it's a black box. Yes, it's wonderful, but only if we know the data that we feed those black box very well, or we end up having some not so divine surprises. And I will tell you very quickly about an experiment, because I worked a lot with medical application, right, a while back. And I heard about an example from a conference that I attended in Mount Sinai and in some connected hospitals. At the very early age of computer vision in deep learning, right, they developed an oncology model. And so they developed an oncology model that was wonderful. It was almost magical. It was detecting tumors at an incredible performance.
Okay.
Incredible. Okay. It was about to revolutionize oncology.
Yeah.
And then we tested it in the field, and the results were completely catastrophic.
Hmm.
So they searched and they discovered something is that the black box, rather than learning if there was a cancer or not, it had learned to recognize the equipment that was taking the pictures. And so it had learned to recognize the equipment in oncology that had the highest probability of having tumors rather than the one that was getting the examination, the digital data from patients that were less likely to have oncology. And the difference was luminosity and calibration of the equipment, but something that was impossible to detect at the human eye. Huh? And so they had invested 18 months, and the model was good to be thrown away because the data that was fed in those black boxes, the black box were very intelligent, but they did something that we call technically overfitting on the results, and it overfitted on characteristics that were not medical diagnosis features. So I want to put that into perspective, and that's where people like Tooraj and myself need to be used for this revolution of deep learning when you're not into those areas where you worked 40 years and you know English very well, you have natural language processing, everything is well known. Or you have computer vision and you know how to extract facial features because you worked decades and decades on it. If it's a new problem, like a smart supply chain or a new diagnosis method or things like that, you have to be very careful with what you feed the black box, or you're going to end up investing a lot of money. And at the end, getting maybe a lot of good performance, you're going to be reassured while you create the model. But when you test it outside, it's going to be catastrophic. So there's caveats to be had here. And so, to me, deep learning is one of the tools that we have in our belts. And
Yeah.
I have a slide that I show all my customer where I put the symbol for AI, like a neuronal with a brain, and on the other side I have a picture of Disneyland, and I say AI is not Disneyland, right? It's not good for everything. So deep learning and AI is one of the tools that we have. Sometimes it's absolutely magical and it's irreplaceable and it's transformed a lot of things, but sometimes good old operational research is going to do much better. Sometimes statistics are going to do much better. So you have to be very careful to use this tool, this new tool that we have that's wonderful, that's deep learning, to use it in situation where you can make the best of it. Or you're going to spend a lot of money and not get the result of your investment. So you have to be careful with that. You have to know your data very well.
Excellent, excellent. Actually, it's a really good point about where the data is and then how where its application is most efficient. So, Tooraj, a question to you. So, a lot of times, some people say like just because you have a hammer, everything looks like a nail, right? So, similarly, we have this deep learning topic, and then everything looks like it can be solved. So, when you actually start with the applications, or whatever the context is there, do people say, hey, I have to start using deep learning, or what is the process? It's like, okay, this problem that needs to be solved, and then this can best be solved by this technique or this deep learning. When does it come into the discussion and picture in real applications?
For sure. Yeah, I see this is a pitfall that people these days are getting into very frequently. They think about AI first and their goals and product second. So first thing they want to do is like, let us use AI to solve this or AI in that. And that has created a lot of problem. Number one, AI is fine. AI is good. It has two specific characteristics that Jeremy mentioned in his previous responses. It's fast. It can process a lot of amount of data, and it can come back with uh, answers to questions that human beings cannot do. That's great. But before getting there, I think the initial step is to making sense of the problem and a solution for that problem in a smaller scale. It could be sometimes drawing on the piece of paper and see if you, as a human, you wanted to solve this problem, how would you
Mhm.
have done it? One good example is we were creating an application for a social application, and one of the features they wanted to they wanted to include was detecting misinformation and disinformation, and they thought AI is a great tool. And so I kind of asked them the same, started having a philosophical discussions with them. As a human, how would you know if a piece of data is misinformation or disinformation? Can you define it for me? And when we started going through that discussion, we got to a point, well, this is something that we solve first. How do we define this before coming to AI and say to GPT, hey, is this disinformation or misinformation? Because again, all of these LLMs or deep learning model reference the existing data, and that would be the reference. Is this something that we want to do or not? So I think the number one thing that people have to do is to just take a step back, try to solve the problem for their own. Once they have a good understanding on how this can be solved, now of course AI, LLMs, deep learning are great tools to make the performance of the solution much higher and much more accurate. This is for cases that we are looking at these solutions as a black box. But of course, if you want to train if you already have your data, you want to train your model, and you have large amounts of data, of course, you can go and start with deep learning. But if you are seeing yourself as a person who want to utilize these models, first try to make sense of your problem and come up with a solution before jumping to the AI, I would say.
Great, great, great. Thank you. So again, so we have the final 10 minutes here, less than 10 minutes, I would say. And I would like to just bring it all home. So Jeremie, I would like to start off with you. I know we touched upon many subjects where deep learning can be used, it cannot be used, and the limitations of the deep learning. But without at the same time where it can be applied, where it has been profoundly, useful. So with all that, Jeremie, if you could bring it all home and also talk about what is happening now, what's going to happen in the future with respect to deep learning.
Yeah, so one of the misconceptions around deep learning is that it's going to be able to be applied everywhere. And in order to conclude, I would say that not only do I have suspicions that it's not going to be the case, but I'm certain that it's not going to be the case. And one of the reasons why is that it doesn't behave very well on tabular data. And on tabular data, other approaches are going to work much better. It can coexist with those data, and they can be connected in some ways, but that's not going to deep learning that addresses tabular data. And then tabular data, that's a huge part of the enterprise knowledge to that day. So that's a large amount of data where a lot of other approaches are going to perform very well and very well for a long time. Now, that's not to say that I'm talking about current deep learning, and deep learning is still an emerging technology. Deep learning is still innovating. So the deep learning of 2024 may not be the deep learning of 2030, and maybe at some point it's going to be performant to do that. But in the industry situation of 2024, if you have tabular data, you're not going to use deep learning. This said, if you have sequences of data, that's going to work extremely well in many cases, given that you do without a few pitfalls, right? And if you have computer vision problem, deep learning reigns king today. So I work a lot with geodata, and with geodata, very often it's akin to tabular data once you processed it. It doesn't work very well. This said, there's a kind of geodata which is geo-related data where deep learning becomes irreplaceable. It's when you have graphs. Graphs of operation on a map where people have relationship to each other. You want to analyze emergency services with respect to the proximity of a hospital or things like that. If you're in a graph environment, then suddenly it becomes a very powerful tool. So it has to be considered very carefully for what it can today in 2024 do very well. And so you can have divine surprises. So I will give you an example. In cybersecurity, right? Cybersecurity, it's log files, right? So you couldn't have something more flat, etc. All the data about zero-day vulnerabilities, its patterns. So you have an environment where people have used the AI to do behavior analytics, for instance. So to look at what the users are supposed to do and to look if the patterns that you see are going to correspond. And here you can use neural networks, but this is a very specific way of approaching it. You don't detect an intrusion right now with a deep learning solution all the time. And remember that deep learning takes a lot of computation. You cannot really do it real time. But where you see incredible new applications is using the generative AI to write defensive code, to write detection code that's much larger, or to write a lot of variants very fast. And unfortunately, it's also used by the other part to write a lot of intrusion codes or to write new intrusion codes. And suddenly, you have data that's typically not adapted to deep learning, but you think of a creative way of applying generative AI, which makes extensive use of deep learning, and suddenly you revolutionize a field like cybersecurity. And I truly believe that, for instance, cybersecurity, we're very active there. We do a lot of research. We have a lot of products, partners where we interoperate with respect to generative AI and deep learning. And I am convinced that it's going to revolutionize the risk and revolutionize the solutions as well. So that's going to be really a disruptive tool, right? And we start to see it as of today. So I would like to conclude saying sometimes, you have rules and you say deep learning is not very well adapted, and suddenly there's a creative way where you see that deep learning is going to revolutionize a new field. And so it's really is a magical time where we have an emerging technology that applies to so many fields that it's almost all powerful. And so it's absolutely necessary to look into it and to try to make the most of it if you want to stay competitive and stay in your market. So that would be my conclusion.
That's great. That's great. So with that, Tooraj, we covered a lot of ground. And coming from your vantage point, you're also doing research in this area as well. So please, tell us what's going to happen next.
Sure. So I go back to what I said at the beginning that to me, intelligence has four components. The last two, skills and evolvability, I think that's where we are going to see a lot on those areas. Now we have very great tools, deep learning, LLMs that can process information, but now it's the time to act on that information. And we see great movements around robotics. Waymo, autonomous driving cars are already doing that. So more skills are going to be created, and these skills do not need to be physical, such as driving, where Waymo does. At APSY, for example, we are the skills that we have is generating applications and code. So I would say small businesses and companies, that's where they, to my what I think is that's where they should be focused on now. If they can add a specific skill that can benefit from what deep learning and LLM can do, that's where they can easily take their business to another level, because that's what it's missing now at this point. A lot of, in terms of where you can find these cases, I would say there are, it depends on the task. If the task is has a lot of variations, normally that you can see it. In terms of approach, Jeremie mentioned creativity. Creativity is something which is still one of the big open problems that has not there. So if the solution you want to find for the task seems to be creative, that's where you can focus on and find the skill sets. And the other thing that, just other than just generic areas, one thing that I think is going to be different in the next 10 years is how our brain, information from our brain is being understood, neurotech. So now they are making a lot of great work of understanding signals that come up the brain, and they want to integrate that with other technologies that we have. So companies such as Neuralink and similar to those, I think those are the things that we are going to see a lot more in the next 10 days, AI and technology being integrated with our bodies and the way we think.
So that is actually a very fascinating thought. So lots of advancements are already being made as we speak with the Neuralink and those kinds of things. So that's great. Hey, Tooraj and Jeremie, so another hour passes by very quickly with this fascinating discussion. Thank you very much for your participation.